The last class we stopped at, we're trying to do the vector differentiation. But today we'll be looking at another interesting area. That area is talking about the gradient, the core, and divergence. So I will give us the definitions of all these areas and the applications of it. They'll give us the law that governs them. Then we can now proceed after that to some of the examples how we're going to be applying it to solve problems. So you are all welcome. Once again, my name is Dr. Segun Oke. For those of you that are joining for the first time, you're welcome. And let's take our pen and paper and write. Can you see my screen, please?
Yes, sir.
Okay. Please mute your audio, except if I ask the question, then you can answer and also mute it again. So we have different differential operators in this case, and one of it is del. And the del, we have the del, everything, we are going to talk three things. Like I mentioned, we'll talk about the gradients, the divergence, and the core. So let's look at the definition of this particular del. Is equivalent to when we have d dx I plus d dy j plus d dz k. Which is at the same time, we also call it to I dx plus j dy plus k dz. So let's start with gradients. Number one, the gradients. Let our phi of x, y, z y, z be defined and differentiable at each point s, y, z in a certain region of space. In a certain region of space, that is, our phi define a differentiable scalar field. Then the gradient of phi is written we call it phi del phi or grad phi, and is defined by d phi equals to the xi plus d the yj plus d the zk. Everything multiplied by phi. So if I want to bring the phi in, now it's going to be d phi over the x I plus d phi over the y plus d phi over the zk. So are we getting it now? Please write it down. Any question, please? Note that the phi, depth phi, define a vector field. So remember, we're talking about different components. The components of depth phi in direction of the units of a unit vector A is given by, if you want it to be on direction of A, we can also get it. If it is star one, if we set the components, let's say the direction of a unit vector A can also be the phi dot A. And is called the directional derivative of phi in the of phi. In the direction A. So let's look at the divergence. How do we represent divergence? 2. The divergence let V of xi, x, y, z be equals to V1, let's say V1i plus V2j plus V3k. So it's also defined and differentiable at each point of x and y, x, y, z, in a certain region of space. That is, our V is differentiable, is defined as a differentiable vector field. Then the divergence of V can be written as dV or dev V. So either of the two, if you have it to be in this form, will be equals to, this will be equals to d dxi plus d dy j plus d dz k. Everything multiplied by dots v1 I, v2 j, v3 k. But remember that when we add, recall, let me remind us, recall that A dot B is the same thing as A1 B1 plus B A2 B2 plus A3 B3, which implies that this, the multiply dot this, we have it to be d v1 the x plus the v2 the y plus the v2 3 the z. Note that del v is not equals to v, it's not the same thing as v del, v dot del. So you have to be careful when you are working on this. Last but not the least is the core. Number 3, the core. So under the core, it said if v of x comma y comma z is a differentiable It's a differentiable vector field. Then the core or rotation of V written as depth cross V or core V or lots V is defined as follows. Is defined by, this is cross, not multiply. Depth cross V is the same thing as d dvx I plus d dy j plus d dz k cross v1 I plus v2 j plus v3 k. Remember, when you have a cross, anytime we have a cross, what do? We find the matrix aspect of it. Then the matrix aspect of this cross means I, j, k is going to be d dx, d dy, d dz. Then we have v1, v2, v3. Then we need to use determinant theorems to find this. When you pick I, if I pick I now, it's going to be what? Let's just do it this way. I pick this I. The row that I pick I will be parallelized, and the column will also parallelize. So it will remain d dy, d dy, and after that, after I have d dy, I will have v2, d dz, I will have v3 minus j. So if I will release I now, I'll pick j. I'll pick j. Also, the column of j will be parallelized. So it will remain d dx, d dz, which is v1 and v3. Plus k. So I will release this one, and I will release this one. I'll keep this one. This will go. It will remain d dx, v1, d dy, v2. So we can now cross multiply. You know, when you multiply this one, this multiply by this, minus this multiply by this. So it's going to be what? dv3 multiply the dy, that's the meaning, minus the v2 multiplied by dz. This is my I. This is what I need to solve to get my I, minus the v3 dx minus the v1 dz, this is my j, plus k. We have it to be the v2 multiplied by the x minus the v1 multiplied by the y. So these are the things I will add for me to be able to solve this problem. So we have the definition of the three operators that we are using. We have the divergence, we have chord, and we have the gradients. But let's quickly look at some laws, some formulas that govern them. So that let's see how we use the formulas. Then we now look at the example. Let's look at the formulas. Number one formula says, anytime I have the V phi plus psi is the same thing as you have the V plus, all these we will use them, or they can ask you to prove them in your exam. Number two, when you have dots A plus B, what does it mean? Simply means the del dot A plus the del dot B. Number three, when you have grad of phi plus psi, same thing as grad phi plus grad psi. Number four, when you have this cross A plus B, is going to be this cross A plus cross del cos B. Or you can have call. It can be call of A plus B. It will be call A plus call B. Then number five, you have the del operator of phi A, the same thing as del operator phi dot A plus phi outside del dot A inside. So number six, is the same thing as del squared phi, which is equivalent to the square phi over the s squared plus the square phi over the y squared plus the square phi over the z squared. So where phi del squared is the same thing, is called this the square the x squared, the square the y squared, and the square the z squared. which is called Laplacian. It's called Laplace of the word Laplace, Laplacian operator. Let's take note of that. You can also ask number 8, or number 7 rather, saying del cross this is the same thing as 0. Then when you have 8, del dot cross A is equals to also 0. So let's look at the example. Then, so that we can see how this unfold, right? And you can lay your hands on as many questions as possible. Once we solve one, you can solve the rest by yourself. Example 1. Example 1 says we should find on the gradients now. We're looking at the gradients. It said if phi of x comma y comma z is equals to 3x squared y minus y cubed z squared. It said find or grad at point 1 comma minus 2 comma 1 comma minus 1. All right. So the first thing you need to do when you are given this solution, just a solution, define your phi, your del phi. Our del phi is what? It's going to give us d dx I plus d dy j plus d dz k. Then don't forget this is our phi. Is multiplying the phi, not dots. Don't make mistakes. This is multiplication. Is 3x squared y minus y cubed z squared. So who can tell us what's the difference between dots and multiplication, please? Yes. Anybody?
Pardon, sir.
Yes, welcome, sir.
Now we will multiply through by the function. We'll multiply 3x squared y minus 3 minus y cubed z into the times dx times d dxi, then plus 3x, like that. We'll distribute it through the grad.
The grad. Thank you. But if it is dots, what do we do?
So it will go I dot I, j dot j.
Yes. Thank you so much, sir. Thank you. That's the difference. Because if it is dots, what we do is we make sure we multiply it with according to the components. So, and the other side we also have x, it will also have ijk. But in this case now we can go ahead by saying d dx. Don't forget is I, d dx of I multiplied by 3x squared y minus y cubed z squared plus j d dy of 3x squared y minus y cubed z squared plus k d dz will be what? 3x squared y minus y cubed z squared. So which is the same thing as Now, the first one, the I component says the X. It simply means your target is X. Anything without X will be 0. So let's differentiate this one. What do we have? When you ask to differentiate this, what do you have? Anybody?
6xy, sir.
6xy. Thank you. 6xy.
6y.
Now the last one is what? 0. 6xyi plus. Now we differentiate the second one with respect to y. What do we have? 3x squared minus 3y squared z squared. Do you agree with me?
Yes.
Okay.
Sir.
The last one will be what? Plus, when you differentiate, there is 0 here. It will be minus 2z or minus 2 what? 2y cubed z. Okay. That is what we have. But we are given a condition, initial value point says at s equals to 1, y equals to minus 2, z equals to minus 1. Substitute them. So you have it to be 6 in brackets 1 and in bracket minus 2, I, plus 3 in brackets 1 squared, minus 3 in brackets minus 2 all squared, and minus 1, everything j, plus minus 2 all squared cube, and minus 1. Okay. So let's multiply it. What do we have? This is 6 multiplied by 1, 6, minus 6, minus 12i, plus, let's open the bracket, 3. When you multiply this one, this is minus. This will be, what do we have? Is it plus?
Yes, sir. It's plus.
This is minus 1. This
Yes,
one
but-
we cancel, which is 12. It will
Yes.
become minus 12. But minus 1 is here, will become plus 12.
Mhm.
Right? J. Then plus, let's see. This is negative 8. Negative 8 is here. Multiply by negative 2. Minus 16.
Okay.
Making positive 16 and multiply by minus 1. Minus. Everything will be minus 16k. So therefore, our final answer will be minus 12i plus 15j minus 16k. Any question? That is how you find your grad. Any question? Silence means no question. Am I right?
None from my hand, sir.
Okay,
For now.
thank you. Let's look at number 2. Find, if they are given direction, how do we do it? Find directional derivative of phi equals to x squared yz plus 4x z squared at 1 comma minus 2 minus 1. In the direction 2I minus j minus 2k. Let's look at the solution. We are still talking about grad. So it's going to be our del into x squared y z plus 4x z squared, which is same thing as I d the x of the entire phi plus j d the y of the entire phi then k d the y d the z rather of the entire phi. So in this case now, we can now begin to differentiate them one after the other. If you differentiate this, what do we have? Let's look at it. Differentiate the first one with respect to x. What do you have? Two x
plus 4
plus 4 z squared.
z squared.
Thank you. I. Now let's differentiate the second one with respect to y.
2xz 2 square z.
No.
Sorry, x square z
X square
y
Z.
right. Other thing will be 0, right?
Yes.
So let's differentiate the next one.
S square y plus 4xz 4x.
This is Z.
Right.
fxz
8x z. Okay. Do we agree with it? Is it correct? Hello?
Sorry, sir.
Yes, sir. Yes, sir.
Yes, somebody asked a question. Go ahead.
Yes, sir. Please, I am lost. How do we have x squared z? How do we get the x squared? Yes, sir.
Okay, let's go back to it. This is what we asked to differentiate with respect to what? Y. There's no y here. Everything here turns to 0, right? Do you agree with me?
Okay. Yes, sir. Yes, sir. I understand now.
Because when you differentiate y, you have 1. 1 multiplied by s squared will give you s squared. 1 multiplied by z will give you z. That's what we did.
Okay. Thank you, sir.
You're welcome. So let's substitute at x equals to 1, y equals to minus 2, z equals to minus 1. Let's substitute it into our equation. What do we have? Let's do it together. For I, we have 2 into 1 minus 2 into what again? Minus 1. Plus 4 into minus 1 squared. I. Plus x.
1 squared
1 squared.
minus
That will
1
be what? Minus 1.
j.
J. plus
1 square
1 squared.
minus 2
No, y is minus 2, yes, plus 8 into 1 minus 1.
minus 1.
Okay. So you will have to get this one. Negative times negative will be positive. 2 times 2 will be 4. Right. And plus 4 here will give you 8i. Do you agree with me? Do we agree?
Yes, sir. Yes, sir.
Okay. Now let's look at this. 1 square multiplied by minus 1 will be minus I, which is minus j. Right? Then we have minus 2 here. Minus 2 plus minus 8 minus 10. Okay. That was what we have at the end of the day. Then we are given a direction. They said the unit, that's not the end, the unit vector in the direction of 2i minus j minus 2k is what? That is, our a is equals to, remember the way we find the unit vector, we did that in the first place. It's going to be 2i minus j minus 2k divided by the square root of the entire a will be 2 squared plus minus 1 squared plus minus 2 squared, the coefficients of each of them. So when you find the square root, what do you have? The one of square root will be what? 2i minus j minus 2k over square root of 9. When you add this one together, will give you 9. Then our a will be 2i over 3 minus 1 all over 3j. Somebody will be asking, where do you get 3? Or how do you get this one you are doing?
Root of 9.
Yes, the root of 9 is 3. Are we together now? Let me just split it. 2i minus j minus 2k over 3. So which is the same thing as 2 over 3i minus 1 over 3j minus 2 over 3k. So that was what we did. But don't forget the definition of unit vector I gave you in your formula sheet. I'll come back to this one. Look at the first, look at it. I think when I was giving you the definition, let me quickly go back to it. So that, look at it. I said here, when you have direction of a unit vector A is equals to this, is called directional derivative of the phi. Look at, so we are using the same thing. So I'll go back. So what I'm saying is this is my A now. I have my A here. Then the required directional derivative is del of phi multiplied by, which is dot A, not multiplication at dot A. Now, del of phi dot A will be del of phi dot A will be E. What is del of phi? The answer we have where this is our del of phi is equals to del phi. That's our answer. Dot A is our the directional with D the other time, the A unit vector with D. So it's going to be 8I, sorry. It's going to be 8I minus J minus 10K dot A 2 over 3I minus 1 over 3J minus 2 over 3K. So how do we solve it? Like I explained the other time, I dot I will give you 1. So that is this dot this will multiply this, and this will now move this. Because they are dots, so it's going to be, that's the essence of removing all the components. So it's going to be 8 multiplied by 2 over 3 plus -1 multiplied by -1 over 3 plus -10 multiplied by -2 over 3. Because K and K will be 1. J and J will be 1. So we don't need to represent, we can't represent it again. And I dot I will also be 1, so they will cancel. So here we have 16 over 3 plus negative than negative positive 1 all over 3 plus minus times minus will be positive 20 over 3. If you do it very well, you have 37 over 3. That is your final answer. Now, these are the 2 questions nature they can ask you when it comes to this particular, the gradients. Any questions so far? Does it make sense to you?
Yes, sir.
Yes, sir.
Okay, let's look at the divergence. Let's see how we can quickly move. So have you guys settled it with your timetable now?
We are still waiting for the final timetable.
Number 1, if A is equals to x squared zi minus 2y cubed z squared j plus xy squared zk. The question says, find der dot A, right? Or they are saying def A at point 1, minus 1, 1. So to solve this problem is pretty simple. Der dot A will be d dxi plus d dy j plus d dz k. Everything dots our A. Let's put it there because that place cannot contain it. Oh, okay, I think I will need to write the entire A so that we can understand what drama we are going to do. S squared z I minus 2y cubed z squared j plus sy squared zk. So can we see the board?
Yes, sir.
Yes, sir. Yes, sir.
Okay, let me just move it up. Plus sy squared zk. Sorry. So now, in this case, it's different from the first one we did. How do we do this one? This is dots. This we differentiate this. This we differentiate this. And this will differentiate this. So we are going to have d dx in brackets multiplied by components. Don't forget. The component of this one is x squared y, s squared z. You will not put I again. Plus d dy minus 2y cubed z squared plus d dz x y squared z. Any question on this? Are we on the same page?
Yes, sir.
Okay.
Yes, sir.
So this differentiation will be what? With respect to x here, will be what? 2sz. The next one will be minus 6y squared z squared. The last one will be plus xy squared. That's it. At 1 comma minus 1 comma 1, we have it to be 2 in brackets 1 minus 6 in brackets minus 1 squared 1 plus 1 comma minus 1. So what do we have? At the end of the day, you have 2 minus 6 plus 2. Or plus 1 rather.
Plus 1, yeah.
So you have it to be minus 3. So that's what they asked you to do. Any question? Any question?
My note is finished.
Your
My note is finished. This
Your-
is the only
why?
call that I'm looking over all the notes.
So I hope you are doing the courses for other, you are doing the facilitation for other courses too.
Yes, we
Yes,
are. You know, this math, it requires a
only-
lot of, you just need to write.
But it's only 3 courses we are doing facilitations now.
No,
On. Which one and which one?
Classical mechanics and
special relativity with us too.
you do special relativity.
Yes.
Okay.
It's not only that. We are doing mass methods. We are doing
We do
geophysics.
even classical mechanics.
We are doing
We
quantum.
does. Quantum
We are
mechanics we does.
almost all of them.
Almost all of them, even geophysics.
Even practical. Laboratory, this thing.
Laboratory practical. So
Yes. So
Okay,
it's
maybe
all
I
of
didn't
them.
capture all the timetable.
It's all of
Are
them.
we are not offering quantum mechanics now? It's classical.
You are not offering, but who we are offering.
We are doing quantum. We are doing quantum. Even the quantum, me, I'm not doing it.
So let's look at this another example before we call it a week. Okay, I'm sharing my screen again. Okay, we're there. Let's look at this example given. Can you see it? Given phi equals to 2x cubed y squared z raised to power 4. They ask us find a del dot del phi, b show that del dot del phi equals to del squared phi. So we need, which means that, remember I told you that del phi, del square is equivalent to the square, the x squared plus the square, the y squared plus the square, the z squared, which is the notes the Laplacian from the word Laplace, Laplacian operator. So that let's look at the, remember we are asked to show that something is equal to something. So let's look at it. The example is very simple. In this case, we look at del phi equals to I did the x of the entire problem to x squared to s cubed rather y squared z4 plus j to s cubed y squared z4 plus k the z so let's solve this one. Can you differentiate it on your own? Let's see. What do you get? Remember the first one you are to differentiate with respect to x. Let's do it together because of our time. We're going to have 6s squared y squared z4 I plus 4x cubed.
Okay, that's one.
Right? Y z raised to power 4 j plus 8s cubed
8s cubed y squared.
Right. So the next thing we need, this is, don't forget, this is just for del phi equals to this. Now, we need to now find, then we need to find these dots, this. So meaning that we need d xi plus d dyj plus d dzk dots plus 8x cubed y squared z cubed Okay. Remember, I dot I will be 1, J dot J will be 1, K dot K will be 1. So we have d dx of I components plus d dy y components plus d dz So how do we differentiate each of them? Let's differentiate each of them. With respect to x now, this will give us 12x
12x y square z raised to power 4
okay, plus
plus 4x cubed z raised to power 4
yeah, then plus
24 plus 24x cubed y raised to power 2.
and z raised to power what? 2. So that's the final answer for this. Then the B aspect of it says we need to show that def dot def phi is the same thing as def square phi. So what we need to do is, that means we need to solve to prove it. How do we prove it? It's pretty simple. Let's look at it. We know that our del dot del phi will be equals to d dx I plus d dy square j plus d dz k dot the phi, the I, the xi plus the phi, the yj plus the phi, the zk. So it simply means component by component the same way. It's going to be d dx of the phi dx plus d dy the phi dy plus d dz divide dz. So at the end of the day, we are proving it by saying it's going to be d square phi over the s squared plus d square phi over the y squared plus the square phi over the z squared. Something is common to them. The phi common to them. Like I said, this square, the s squared plus this square, the y squared plus the square, the z squared, all multiplied by phi. It's the same thing as. So I show it. I just prove it. Any question? So in next class, we'll continue with the core before we move into integration. Any question, guys?
Very much, sir.
You're always welcome.
None from my hand, sir. Thank you, sir.
You are always welcome.